All right, we're going to talk about lines and angles. This is section 3.1 and 3.2. Okay. So parallel lines are coplanar lines that do not intersect it. So here's a symbol for parallel to. So make sure that the big thing is that they are coplanar, because we do actually have lines that don't intersect in 3 dimensions that are not parallel. Skew lines are non-coplanar and they are not parallel and do not intersect. So what happens is if you look in a room, the top ceiling and the far back wall, the corners, they don't intersect, but they're not in the same plane. Parallel planes are planes that do not intersect. So here's our diagram. So let me pull up this stuff here. So, oh, we can't see it. So let me put in some information here. So let's go A, B, C, D, E, F, G, H. And so what it wants to do is it wants to know all segments that are parallel to AB. So here's AB, okay? So remember, they have to be in the same plane and they have to not intersect. So if I have AB, I also have DC. So DC is parallel. Well, what about the plane on the back side? So that would be EF. And then this is the hard one to see, because what if I had a diagonal plane coming from AB diagonally down to HG? So HG is also parallel to AB. Okay. Which segments are skew to CD? So here's CD. So skew means they're not in the same plane, but they don't intersect. So that would be AE and BF. Okay, what are two parallel planes? So now we just have to name parallel planes. Well, they're kind of the opposite ends of this box. So I'm going to say plane A, B, C. So I'm taking the top is parallel to plane E, F, G. Okay, there are some others that you could use, but that's the one I'm going to kind of name there. What are two segments parallel to plane ABCD? So here's ABCD. So I want two segments. So I'm going to pick HG, and let's just go EF, since they are both parallel. But I could have picked EH and FG and any combination of those, because it's not saying the segments are parallel. It's just saying which ones are parallel to it. Okay. So here's our next kind of diagram, and hopefully you can kind of see this. So I have line AB, I have line CD, and then I have EF here. Okay. So transversal. Transversal is a line that intersects two or more coplanar lines. So in this example here, EF is my transversal. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of the transversal. So in this example, 3 and 6 are alternate interior angles, and 4 and 5. Same side interior or consecutive interior angles are interior angles that lie on the same side of the transversal. So angle 3 and 5 here are same side interior. 4 and 6 are same side interior also. Corresponding angles. Corresponding angles lie on the same side of the transversal, so EF here, and in corresponding positions. So here, 1 and 5 are corresponding. 2 and 6 are corresponding. 3 and 7 are corresponding. 4 and 8 are corresponding. So they have to lie on the same side of the transversal and the same side of their line that they're working with. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. 1 and 8 are alternate exterior. 2 and 7 are also alternate exterior. Name a pair of alternate interior angles. So we've kind of gone over this. So my alternate interior, I have to be inside my two lines, and on opposite sides of my transversal. So I'm going to say angle 3 and angle 6. Name a pair of same side interior. So I have my two lines. I have to be on the same side, on the inside, same side interior. So this is interior, same side of the transversal. So I'm going to say angle 3 and angle 5. So these two right here. What are 4 and 8? So here's 4, here's 8. So they're on the same side of the transversal, same side of their respective lines. So these are corresponding. What are 2 and 7? So here's 2, here's 7. So 2 and 7 are on opposite sides of the transversal, so we know that's alternate. And they're on the outside of our corresponding lines, so this would be alternate exterior angles. Okay? And I kind of abbreviated that there. All right, so 3, 2. So this is something you should work real quick on, kind of on your own. So I'm going to put these up here real quick. Oh. So this is something that I like to do with my students here to kind of get them thinking about this idea of transversals and parallel lines. So try and work this out real quick and see what conclusions you come up with. Pause the video and then come up with the conclusions. We'll see if they're right. So properties of parallel lines. So same side interior angle postulate. So same side, if a transversal intersects two parallel lines, then the same side interior angles are supplementary. So angle 3 plus angle 5 equals 180. All right? So angle 3 plus angle 5 equals 180. Which angles are supplementary to 6? So when I look at this here, here's 6 here. So supplementary, I know 4 is because it's same side interior and also 5 and 8, right? And I would actually know 1 is too because 1 and 4 are vertical angles. All right? So alternate interior angles. If a transversal intersects two parallel lines, then alternate interior angles are congruent. Angle 3 and angle 6 are congruent. So they're the same measurement. Angle 4 and angle 5 are the same measurement. All right? Now, so last time we said same side interior. Well, we're going to kind of look at this. So our given angle 3 is alternate interior to angle 6. And we want to prove angle 3 is congruent to angle 6. Okay, so here's my statements. Here's my reasons. So my first one, angle 3, alternate interior to angle 6. That's given. Okay? All right. So I have 3, I have 6. Remember, the only thing I have is and I probably should say that AB is parallel to CD because we have to have parallel lines for this to work, okay? And EF is transversal. All right, so the only thing we have before is same side interior, right? So angle 4 plus angle 3 is equal to 180. Why is angle 3 and angle 4 equal to 180? Well, if you remember, they're a linear pair. Okay? And angle 3 is, so angle 4 plus angle 3, angle 6 is 180 because same side interior angles are congruent in parallel lines, right? Remember our last postulate said that they're congruent. Now, both of these are equal to 180, so I'm going to set them equal to each other. Angle 4 plus angle 3 equals angle 4 plus angle 6. That's just substitution. Okay, now they both have an angle 4, so I'm going to subtract those out. Angle 3 equals angle 6, that's subtraction. We're really close now. Notice that we have equality. We don't have congruency yet, but we can switch that over. Angle 3 is congruent to angle 6. That's just definition of congruency. So now we've proven that alternate interior angles are congruent. Okay. So corresponding angles. So corresponding angles, if a transversal intersects two parallel lines, then corresponding angles are congruent. So angle 3 and angle 7 are congruent. Okay. So 1 and 5 are congruent. Okay, we want to prove this again. So we're gonna say 1 and 5 are given. So given. Angle 1 is corresponding to angle 5, and AB is parallel to CD. Okay, so I have my statements, I have my reasons given. So I'm going to just write this. Angle 1 corresponds to angle 5, AB parallel to CD. Okay, so that's my given. All right, so I'm really trying to, and my prove is angle 1 is congruent to angle 5. Okay? So 1 is congruent to 5. I now need to prove that these are the same. Okay? Well, what's unique about 1 and 3? Well, angle 1 plus angle 3 equals 180 because they are definition of linear pair. Right? They're a linear pair. Well, what do we know about angle 3 and angle 5? They're on the same side interior. So I could say angle 5 plus angle 3 equals 180. Same side interior angles are congruent in parallel lines. Right? So same side interior. They're congruent. Now, I'm going to set these equal to each other. Angle 1 plus angle 3 equals angle 5 plus angle 3. That's substitution. Angle 1 equals angle 5. Subtraction. And then angle 1 is congruent to angle 5. Definition of congruency. Okay? So now we've proven that corresponding angles are congruent. Okay? Alternate exterior. So the alternate exterior angles theorem, if a transversal intersects two parallel lines, then the alternate exterior angles are congruent. Okay, so angle 1 is congruent to angle 8. Kind of that same proof that we were talking about. Okay, so here I have, this is 105. So if you can't see this angle here is 105. So I have multiple parallel lines here. So find angle A. So when I'm here, I have 105. So corresponding angle says this is 105. And I is corresponding to A, so it's 105. All right? So all these are two sets of parallel lines. And so I get to use corresponding angles. I get to use alternate interior. I get to use vertical. Angle G. So now angle G, so if this is 105, remember E is in the same side, so this has to be 75. And angle G has to be 75 because it's vertical. Okay? Angle I. Well, we already talked about angle I because that's how we use it to find A. So it's 105. Now you see when you're dealing in parallel lines, you're only going to have two different values. Okay, so find all angles that are 105. I'm going to just draw them up here. So I know O is because it's vertical. K is because it's alternate interior. I is because it's corresponding. We already found this. So D is, F is, and H is. Okay? So that kind of gives you an idea how we can use that vertical. Now supplementary. So all the other angles are going to be supplementary to it, right? So B, C, LJ, NP, EG. They're all supplementary to angle M. Okay, so let's look here. So here I have two parallel lines, and you'll see them have an arrow here. It probably got weeded out when I had to change my background. But I have angle 1 is 65. Okay, and angle 3 is 40. Okay, so we want to know that. Well, what's unique about, these? So angle 2 is not the same side as angle 1. It's not same side interior, so we need to be careful there. Okay, so find angle 2. Well, all of this is same side. So angle 1 plus my interior, so angle 2 plus angle 3 have to add up to 180. So this angle here plus the sum of these angles, because this is my same side interior. So I know some of these. This is 65 plus angle 2 plus 40 equals 180. So angle 2 plus 105 equals 180. Going to subtract my 105 over, so I end up with 75. So angle 2 is 75 degrees. All right. What would a math student say to a fat parrot? Polynomial.